model which can give high accuracy of predicting the disease. Now, for predicting diabetes predictive model, different machine learning techniques are used. Among those different machine learning techniques, we have choose logistic regression method to build this model because it is very easy to build using this logistic regression method, and also it is giving us very high accuracy, that is 77.27%. Pretty good, nice. Now let's dive into the code. First thing we have to do is importing the libraries that are required for the code. Here the libraries we require are NumPy, Pandas, Matplotlib, Seaborn. Now after importing the libraries, the next step is importing the dataset. Now how to import the dataset? It is very simple. By reading the CSV file, that is our diabetes dataset, using Pandas library function. We use pd.read CSV to read this file. See, and after printing the data, we are stored in data, and after printing the data we can see the data here. Now we are printing length of data to know the number of rows in the data and also the number of patients this data contains. And after that we are printing data.columns to know number of columns and what type of attributes the dataset contain: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. These are the variables that dataset contain, and this outcome is the target variable. It is of two class, that is class 1 and class 0. Class 1 represents that the person is having diabetes, and class 0 represents that person is not having diabetes. Now here we are just eyeballing the first few rows of dataset by using data.head function, you can see, and eyeballing the last 10 rows of data by using data.tail function. Yes. Now after importing the dataset and after understanding the dataset, the next thing we have to do is explore the data. Now how to explore the data? By using two main functions, that is .describe function and .info function. .describe functions gives us the descriptive statistics of the data like mean, standard deviation, etc., as you see here, and .info gives us the information about the data. Here you can see the information about the data, and after we are using this line to check the distribution of data in target variable. That is, after printing this, you can see that 65% of data in our model does not have diabetes, and 34% of the people are having diabetes. Now we can visualize the data using different graphs. Here we can check the distribution of data in target variable using bar graph. See, this is the code, and after running we can see the bar graph here. 0 represents number of patients not having diabetes, and 1 represents number of patients having diabetes. 500 of the people in our dataset does not have diabetes, and almost 278 people are having diabetes in our dataset. Now we can plot the pie chart also, and we can see the pie chart here. 65% of our data does not have diabetes, and 34.9% of data are having diabetes. Now also we can plot histograms. This is to know the distribution of variables in the data. Here is the histograms of each variable in the data: age, BMI, blood pressure, diabetes pedigree function, glucose, insulin, outcome, pregnancy, skin thickness. Now data.isnal.sum function is used to know whether the variable in dataset contain missing values or not. So after running this, we can see that any of the variables are not having any missing values, so our data is well prepared, and we have explored the data because to know whether our data is having missing values or outliers or not. If they are present, we can treat them using different methods like imputing, capping, variable transformation, etc., etc. Now we are entering the main code of the data, that is, we are making trained data sets to train the model. But before that, first thing we have to do is separating the dependent and independent variables. Now the dependent variable is taken into variable y, and the independent variables are taken into variable x. After that we are scaling the data, that is feature scaling, that is nothing but normalizing the set range of values in the data. After feature scaling, we are splitting the data set into trained data and test data. Now what is trained data? Trained data is used for training the model, and test data is used for describing the performance of the model. Now after splitting the train and test data using this scikit module, we are fitting classifier to the training data set. As we know, logistic regression is a classification algorithm. We are fitting the trained data into classifier in this way. You can see in the code. After fitting, we are predicting the test set results by using classifier.predict of x test. Now we can know the predicted test set results. These are the predicted values 1, 0, 0, 1 as you see, and predicted probabilities are these set of values as you can see. And now after that, the main thing, we have to calculate the evaluation matrix. One of the main important metric is confusion matrix, which we can import using scikit-learn module. Now we are importing confusion matrix using sklearn.matrix. Now after printing confusion matrix, you can see here this is the 2 into 2 matrix, because our outcome has only two types of classes, that is class 0 and class 1. So from this we can say 81 of the 81 values we have predicted positive and actually they are positive, and only 9 we are predicted positive but actually they are negative, and 26 of the values are actually positive but we have predicted negative, and 38 of the values are actually negative and we have predicted negative. So from these values we can say that our model is pretty good, nice. Now we are entering the main part, that is calculating the accuracy. We can calculate accuracy, precision, recall, F1 score by using sklearn.matrix. We are importing those by using sklearn.matrix, and after running the code we can see the results. 77.27% coming to be accuracy, and precision is coming to be 59.37%, and recall is coming to be 80.85%, and F1 score is coming to be 68.46%. These values are pretty good, nice. And here just we are checking the precision recall curve, and after running it we can see this is just for understanding. As our precision increases, the recall gets decreases, or vice versa may be happening. So finally, we are importing classification report from sklearn.matrix. This classification report is used to measure the quality of our predictions. In this classification report, we can see all the accuracy, precision, recall, and it gives the details of everything, our metrics. So after printing this classification report, we can see here the precision, recall, F1 score, and support and accuracy is coming to be 77%, and this is a pretty good accuracy, right? So we have built this predictive model for predicting the diabetes disease with high accuracy using logistic regression, and that's it.